Hello guys, so today we are going to perform a half-wave rectification. This simply means we are going to convert an alternating current to a direct current by passing only the half of the AC waveform. In order to do this, we need to create a DC circuit and we need components. And as we see here, our circuit wizard is already opened and we can find most of the components at the gallery. So we click there and the components we need to create the DC circuits are, first of all, the AC supply, which is our alternating current supply. So we go to the power supply, which we can find it in the gallery. We go is top, we click, we select the AC voltage source, we click, we drag, then we release. Secondly, we need the center tap transformer and it can be found at the inductor side. So we go to the inductors, we click, we go for our center tap transformer, we click, we drag, then we release. So thirdly, we'll go for our diode, which can be found at the semiconductors. So we scroll. So here it's written discrete semiconductors. We click on our diode, we drag, then we release. And also we have to take note that the position of the diode will determine whether current will flow or not. So in this case, we have to rotate the diode in order to face the direction where currents can flow. So you see the buttons at the top here. We click on it to rotate. And lastly, we need our load, which is the resistor. So with the resistors at the gallery, you will just find resistors there. So here's the resistor. We click, we drag, then we release. So now we have to set our voltage and frequency to the normal Ghanaian voltage that we know. So we double click for the AC voltage source property to appear. We set the RMS value again. So we first claim the value over there, then we insert 240. That's the normal voltage range. Then we come to the frequency, which is 50 Hertz. So now our voltage source is ready. So now what we have to do is to connect the wires. So we position it well so that it will all be aligned. So we are positioning it for all to be aligned well. We tap the tip to connect to our source. Now to our diode. Now to our load. Back to our transformer. And then now we are going to run our circuit to see whether current will flow or not. So we go to this button, we press, then we run. So as we can see, the current is running through the circuit. In order to see the rectifier's outputs, we can use the oscilloscope, which we are going to get from the gallery. So we go to the virtual instruments, we click, we tap on our oscilloscope, we drag, then we drop. So now we are going to connect channel 1 to our circuit. So now we connect the lines to our load. And then we connect the second one to the ground. We connect this channel 2 before the diode to get the AC waveform. and we connect the negative side to the ground. So in order to see this on a graph, we have to right click on the oscilloscope. We select the add graph, we click on it, then release. We need to expand the graph for us to see it well, so we're expanding it. Okay, so now we are going to run and see the output of the wave. So we can't really see it well, so we are going to click on it, go to graph, fit to data, we click. As we can see, now the blue lines which are going up and down is the AC form of this circuit, and the red lines is the DC waveform of this circuit. The output, that's the red, is pulsating. This is typical of a half-wave rectifier. This is because the diode conducts during only the positive half cycle of the AC. That's the blue one. We can filter and use voltage regulator to get the more DC-like output. I'll try and demonstrate this in my next video. Like, share, and subscribe. Thank you.